Okay, so today we're going to be discussing Newton's law of cooling. And there's a question here that says, just before 6 p.m., students enter the classroom to find Mr. Fees dead of an apparent homicide. Everyone said they saw it coming. At 6, the temperature of the body is 80 degrees, while at 7 p.m. it was 75 degrees. It took a while for the campus police to get through the party. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? And so we have an equation here for Newton's law of cooling where T of T equals T ambient plus T object minus T ambient e to the negative KT, where T represents temperature, T ambient is the temperature of the room, T object is the temperature of the object at some given time, K equals the decay coefficient constant, and T equals time, little t equals time. So, moving over to our equations here to solve for the first question. The first question asks to determine and discuss the value of K. So we have here givens. We have our little t at 1 hour, which would be from 6 p.m. to 7 p.m. And we have that going to be the body at 75 degrees. Now we showed that the initial body was at a temperature of 80 degrees at 6 o'clock. So to solve for the first question, we have to go with T's of T, where we have the T ambient plus T object minus T ambient e to the negative KT. So we're going to go ahead and put down 75 degrees here, because this is going to be temperature in respect to time, equals the T ambient, which is the constant room temperature of 70 degrees, plus 80 degrees of the body temperature of object given at some time, which is going to be 1 hour, minus 70 is e to the negative KT. Now this t right here is going to be 1 because we're doing 1 hour. So now we're solving for k here, which is going to be 75 degrees equals 70 plus 10e to negative KT. I subtracted 70 from both sides, brings this to a 5 down here, and equals 10e to the negative KT. Now, afterwards, we have 0.5 by dividing by 10. 0.5 equals e to the negative KT. Now, in order for us to solve for k, we're going to have to actually bring this down to a natural log, because natural log of e equals 1. So we're going to try and cancel that out, which we do so right here. We bring down the exponents, set this ln to 0.5, and then negative kt ln of e. And then we're going to divide by negative kt. Remember, t is 1. So we're going to divide by negative k, or negative 1, and negative 1 here, which gives us k equals negative ln of 0.5. And that's how you solve for k for question A. Now question B is asking to determine and discuss the approximate time elapsed to the nearest tenth from time of death to time of discovery. So what we went ahead and did was we went to go ahead and say that the average body temperature is 98.6. That's our standard measure. And we're going to go ahead and set the same formula of T's of T, where T equals 1. So let's see, 70 plus 80 minus 70, e ln of t. Actually, in this portion, we're actually going to solve for time. So T does not equal, we're going to solve for time. And in order for us to do so, we're going to go ahead and now do a subtraction of this 70 degrees from the 98.6. And we are going to get a 28.6 equals 10e to the negative ln of 0.5 t. That's going to be divided by 10 here. And afterwards, we're going to get a 2.86 equals e to the negative ln of 0.5 t. After that, we're going to go ahead and divide by negative ln of 0.5 on both sides. We're going to actually get a t value which approximates to about 4 hours. So we are going to say that the time of death to the time of discovery is approximately 4 hours. Now the last question here says, discuss and determine the approximate time of death. And it says to go ahead and get the 4 hours that we picked earlier here, and we're going to go ahead and subtract it by the 6 o'clock, so we are getting around 2 o'clock. That's how you solve for number 3.